Okay, so I am out today, and this is your video notes for what we're covering today. We are actually going to move 2.2 to next class. So I know we wrote down the date for last class, but we're moving that one. Today, we are going to work on 2.3. So today is 11/07. We're going to do 2.3 today, and I'm going to give you your schedule of quizzes and tests, or just quiz and test. Okay, so we're going to do 2.3 today, and we're going to finish 2.2 next class, just for scheduling purposes. So you have a take-home quiz next week when you return on Tuesday. This is a Tuesday take-home quiz on Tuesday. That's the day after your 3-day weekend. Okay, the day after your 3-day weekend. And today's homework is stretching and shrinking 2.3 practice. And it's going to be pages 47 and 48. That's going to be due 11/12. We change this one. That's not due on the 12th. That's due on the 14th. It'll be handed to you on the 12th. Go ahead and write that down. If you need to, go ahead and pause the video whenever necessary. Erase this portion over here because we didn't get to 2.2. We'll get to that one later. Okay, we are on page 19. And on page 19, we're going to go over this page. What I want you to do is pause whenever you need to, copy down, make sure you're watching the video. Whenever there's work time, please use the work time, pause the video, and resume after you guys have been allotted your work time, so that way you can check to see how your work matched up. Okay. Alright, so things to know. We know that the pre-image is the original figure. We've talked about that before. Pre-image is the original figure. Okay, this is wherever the starting figure. Okay, now that can change based on whichever information you are going from. Okay, this is your known information. Okay, now sometimes you'll have two figures, and your pre-image is where you're getting information from, and then your image is your new figure, new shape. This is the one you're trying to find information on, or your unknown information. Usually your variable, your x, your whatever letter they're using. Okay. Scale factor is the number that you multiply by in order to get the pre-image length to the side lengths of the image. Okay, you should bold these items. These items are important. So the pre-image to the image. Okay, now your formula for the pre-image to the image will be image over pre-image. We have written this down before, okay, and we've written it down again. That should tell you that it is very, very important. Okay, so keep that in mind. Your formula for scale factor is image over pre-image. Now those can be numerical values, or they should be numerical values, and whenever you use these, make sure you use known values first. Okay, what that means is don't put the variables in this one first. You have to use the ones where numbers are available to you. Okay, And you're going to be comparing, whenever you put the image and the pre-image numerical values there, okay, you must always use corresponding side lengths, okay? So for two figures that are similar, there must be the following correspondence between the figures. The side lengths must be multiplied by the same number. That same number is scale factor. And the corresponding angles and are the same size. That means they're just similar, okay? That means the angles are the same. Whenever we talked about similar figures, this is same shape. Okay, that's the same shape. Okay. All right. Says the rectangles below are similar. That's a requirement, okay, to find scale factor. Okay. The pre-image times the scale factor will equal the image. Okay. I'm trying to highlight all my scale factors in green. Okay. My pre-image times my scale factor. Okay, so let's try and color coordinate a little bit. Here's my pre-image value, okay, and here's my image value, which will be blue, okay. So this 2 centimeters came from right over here on the pre-image, okay. Then they multiplied that by the scale factor, and here's that times 3, and then they'll get the image value, which is 6, okay. They're using the scale factor to get the value of the new one, okay. They do it again down here. Here is my pre-image, 3 centimeters, 3 centimeters. Here is my scale factor, and here is my image and my result, okay. Now, the hard part is not doing this because this is already filled out for you. This is already known for you. The hard part is here in the next question, we don't know what the scale factor is. That is a mystery, okay? So our goal is to figure out what that number is. Now, these numbers are the same numbers, okay? These aren't two different numbers. They must be the same, okay? Scale factor is the same for all side lengths. Okay, so if it goes from pre-image to image, it should be the same side lengths. Okay, sorry, it should be the same scale factor. Alright, so let's figure out what this scale factor is. I'm going to write our scale factor formula down here. Okay, scale factor. Okay. And our scale factor is determined by image over pre-image. So image over pre-image. This formula is already on the top of the page, but I'm bringing it down here so you can see it while it's being used. Okay. Now let's determine our image and our pre-image. Okay. Well, here is my pre-image, and it's now gone to the big shape. Okay. And here is our small image. Now, items can shrink and get smaller. That's fine, but what you'll notice is your scale factor will be smaller. It's not going to be like a 2 or a 1. It's got to be less than 1. So I'm going to find my image number. My image value here is 9, so I'm going to put that here. There's my image. It's 9. And then I'm going to find my, sorry, that's my, I got that backwards. Let's fix that. Sorry, go ahead and erase. Right, so image is here, 3. That's going to go over there. 3. My pre-image is the red one, which was our 9. Okay, that 9 is going to go down here. Okay, that is our scale factor. Our scale factor is 3 over 9. Kind of a weird number, so we're just going to reduce it a little bit, and we're going to make that 1/3. Okay, that means to go from the big shape, pre-image, to our small shape, image, I have to multiply by 1/3. They have to be the same number. That's here. 1/3, 1/3. Again, you have to use your known values. Okay? To use your known values. Okay? Now, if you set them up over here, you can also use image, pre-image over image. And you can have the 2 on top and the 6 on the bottom, and you reduce it, you'll get it 1/3. Okay? And that 3/9 that we had earlier, our 9 down here and our 3 over here, is the same thing here. 3 and 9 reduced make 1/3. Okay, make sure you copy that down and get all this organized correctly, please. This is you'll see this at least, at the very least, very, very clearly for this unit and the next unit. We will still be using scale factor in further units, but you will see this equation a lot of times. Okay, image over pre-image. You'll see that equation a lot. So do not get confused with that. Okay. All right. We're going to do some practice, or we're going to do some examples. It says, which pairs of rectangles above are similar, and how do you know? Okay, so you need to find if two shapes have a scale factor between corresponding sides. Okay, so let me repeat that. You need to find shapes that have corresponding sides, short side to short side, long side to long side, and have the same scale factor for both. Okay, so spend about 8 to 10 minutes or so working on this. If you guys aren't working, so we'll just play the video for the rest of the time. Okay, so make sure you give it a try, and pause the video 8 to 10 minutes or so. Alright, so here is what it might look like for you. If I'm going to suspect a couple, I think I'm just going to start over here. Okay, and I'm going to compare corresponding sides. So I'm going to compare the short side to the short side of each of those two rectangles. Okay, I wrote short side down here on the bottom, and from shape L, or rectangle L, we go from one side length, that's a 1, to a 2. Okay, and it turns into a 2. Okay, so I need to figure out what the scale factor is. Okay, this is my pre-image, and this is my image. So I'm going to check to see my scale factor. If my scale factor, whatever it is, doesn't mean that I found a similar shape. I have to check the long side also. So my image is going to be 2, and my pre-image is going to be 1. My scale factor, okay, my scale factor for these two shapes is going to be 2, or 2 over 1. Okay, and that's going to be shapes L and J. This is shapes L and J. L and J. Okay, and now I'm going to do the same thing because it has to work for both sides. I'm going to check the long side and the long side. Okay, this one has a long side of 4, and this one has a long side of 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's got a long side of 8. Now it sounds like, it looks like that's gonna work. So, but I'm gonna check it anyway so I can see the work. Okay, for the long side. Okay, I go from the pre-image, and I have to keep my pre-image the same. Okay, which is 4. This is my pre-image. I can't change it when I'm checking. I can't go from small to big this way and then big to small because I'm switching pre-images images. Okay, so my pre-image was the smaller shape. I went from 4, and then it turned into 8. So let's check to see what our scale factor is. Should multiply there. Multiply by 8 over 4. Okay, and this is again our scale factor. Now, are our two scale factors the same? Okay, is 8 over 4 the same as 2 over 1? 8 over 4, is that equal to 2 over 1? Is that proportional? Is that a proportional ratio? Yes, this is. These are similar figures because their scale factors are the same. If I reduce this by 4, I get 2 over 1. Okay, so I know that L and J are going to be similar. Okay, so far I know that shapes L and J are similar. Okay, are there any more? Yeah, there's a couple more. So I'm going to find the rest. I'll do the work here in case you want to see it. What I recommend that you do is maybe take a break, pause it for another 5-10 minutes or so, and you can give it some practice. Okay, so go ahead and pause it for 5-10 minutes to practice. All right, so after practicing, you should know that these two didn't work. Okay, this one did. That had a side length of 3, and this had a side length of 12. Okay, so we can check our scale factor for each one of these. So from L to N, this one is times 3, and from 4 to 12, that's times 3. So now I know that L and N are similar. Okay, now it says one more. Well, I've paired this one and this one and this one. Okay, so what that means is if these two are a pair and these two are a pair, therefore this one and this one are also a pair. Okay, so the last one that I should have will be shape J and N. Now that one might be a little bit trickier because finding your scale factor from those two is a little bit harder, going from 2 to 3 and from 8 to 12. Okay, that's times 3 over 2. Times 3 over 2. Okay, it's getting a little 1.5 times bigger. Okay, right, for each pair of similar rectangles, find the scale factor. We kind of did that already, so we're just going to write these down. If we go from L to J, our first one over here, okay, our scale factor was 2. Our scale factor was 2 over there. Okay, and then from L to N, our scale factor was 3. L to N, our scale factor was 3, and our last one from J to N, our scale factor was 3 over 2. From J to N, our scale factor was 3 over 2. Okay. So now what we're trying to do is find the relationship of perimeter and area. Okay. So we're gonna find a rectangle. We'll do each one of these. We'll do each of these 3 letters. We'll do rectangle L, J, L, oh, it doesn't matter, L, J, and then N. You're going to find the perimeter of those, and then you do the same thing for the area. If you don't remember how to find the area, this one is the formula for this one is length times width. Length times width, or base times height, they're the same thing. And this is add or sum of all sides. Okay, so go ahead and take a break, 5, maybe 8 minutes. Okay, you're only adding and multiplying here. It shouldn't take you very long. Okay, 5 to 8 minute break. Okay, so we're going to start with L. L is 1 side length of 4 side length, so that's 1 plus 4 plus 1 again plus 4 again. So add those all up, 4 plus 4, 8 plus 1 plus 1, that's 10. Okay, get those out of the way. So the perimeter for L, so the small one, yes, should be 10. Okay, rectangle J, 2 plus 8 plus 2 plus 8. Okay, 8 plus 8 is 16, plus 2 plus 2 is 4. That gives us 20. Get it out of the way. This one was 20. And our largest rectangle, N, we can make a prediction. I got 12 plus 3. I should have another 12 plus 3. Okay, so 15 plus 15, that'll give me 30. Okay. All right, now let's go to the area. Okay, the area for the small one down here. Let's do this in a different color, dark blue. 2 times 8 is going to be 16. So that's our area. We multiply length times width. Okay, so this one is 16. J, oops, I got that backwards. That was J. That was J. And then over here, the small one, 1 times 4 is 4. Okay, and lastly, the large one is 3 times 12, which is 36. Okay, now describe the relationship between the perimeters of the two similar rectangles and its scale factor. And we'll do the same thing with describe the relationship between the areas. Okay, well, take a break, answer 3 and 4, again another 5 or 10 minutes, and then come back to it. Alright, after you've paused the video and you worked on this, this is what we're looking for. You're looking for a relationship between these two items, 10 and 20, that's times 2. Between these two items, that's times 3. Okay, and we saw that. That was our scale factor. And here it is, times 2, times 3. Okay, now, when we do the same thing, well, let's write that down. Okay, let's get that out of the way. Now, it says the relationship between the perimeters and rectangles. Okay, so the perimeter increased by the scale factor. Okay, for example, if we went from L to J, the scale factor was 2, and the perimeter was also times 2. Okay, so the perimeter and the scale factor were the same, or the perimeter factor, I guess you could say. Now, is that the same thing with our areas? Is that still times 2? Nope, that didn't work. It didn't match the scale factor. To go from 4 to 16, we had to multiply by times 4. Okay, so the area does not increase by the same factor that the perimeter does. This one is times 2. Okay, so let's see the other relationship here. This one was times 3, and then from here to here, that was times 9. Okay, I should do this in red, just like the other one, times 9. Okay, so describe the relationship. Well, area increased by more than the scale factor. Okay, so it was not the same amount of the scale factor, it was more. There is a relationship between these two numbers. We're not covering it today, but if you can make the conjecture, okay, that's another math term for you. If you can make the leap to the idea of what that represents, that would be get you quite a bit ahead to the next unit or two. Okay. After studying the mouths in the diagram, okay. Oh, sorry, I forgot to mention. These are the mouths from the mugwumps. These are the mugwump mouths, the little rectangles in their mouths. Okay. Marta and Zach agree that rectangles J and L are similar. Okay. Marta says the scale factor is 2, and Zach says it's 0.5. Is either of them correct? How would you describe the scale factor? How would you describe the scale factor so there's no confusion? Okay. So let's look at J and L. Okay. And that's our 1, 4, and our 2, 8 rectangles. So I'm going to draw them down here. L, I think, is our small one. Yeah. Okay, so let's draw them. Just going to go do a quick sketch. 1, 4, that's L. And then we have our 2, 8, and that's our J. Okay? Now, we came up with 2. This is the one that we came up with this way, times 2. So we know for sure that Marta is correct. So we know Marta is correct. Now, does that mean that Zach is incorrect? Well, not necessarily. We went from the small one to the big one. What happens if we go the other direction? Okay. What if we went this way? What if we went from big one to small one? Okay. Well, if we went from big to small, if we went from J to L, okay, we would have the pre-image. This would be our pre-image. Okay, and this would be our image. Okay, and we go from 2 and we go to 1. To find our scale factor, 1 over 2. This is now our scale factor if I go from the big one to the small one. Okay, erase this a little bit. There you go. 1 to 2. Okay, now is Zach correct? Yes, Zach is also correct. Marta is correct, and Zach is correct. Okay, now they are both similar to each other, and the way that we can clarify, okay, to clarify any confusion, okay, you should identify which shape is the pre-image, and image. If you determine which one is the starting, which one is the ending, you know that it's getting bigger or smaller. Okay? All right, number 2, explain how to find scale factor from a figure to a similar figure. Okay? In order to find this one, use the scale factor formula, and I'm going to write it down. Image divided by pre-image, okay, and place, this is the important part, known values of corresponding side lengths. Corresponding side lengths. What that means with corresponding side lengths is that you want to use the long side to the long side, short side to short side. You cannot compare a long side image to a short side pre-image. It's not going to work. So long to long, short to short, whatever it might be. Think of Dr. Evil. Make sure that they're both using their right hand. So I'll make sure you're using the same side length. Okay. And does scale factor change the angle size? No. This one is definitely a no. No. Because similar figures, okay, because similar figures have the same shape, okay, and that shape is referring to angles. For example, if these two are similar, okay, they're both rectangles, which means that this is 90 degrees, and just because this one is twice as big does not make that 180 degrees. That's still 90. Okay. All right, we're gonna stop there. Okay. Go ahead and pause the video where you need to. Copy things down. Okay. Your homework is again pages. I believe we wrote down 46 and 47. Let me double check. Oh, sorry, 47 and 48. Okay, 47, 48. I'm gonna go do the first problem for you guys or with you guys. Not on 47. Okay, not on 47, but we're gonna do one of the problems on 48. Okay, and then actually, I'm going to do one problem, page 49. It'll be very, very similar to these problems here, but I'm going to do a problem 48, and 48 will eventually be a homework assignment, but I want to do this one because this one has a rectangle. Okay, so here I'm going to outline our two shapes, and it tells us that they are similar, okay? And just like here, it tells you that these figures are similar, okay? So on page 48, I'm going to do question number 3. Okay. And I'm going to highlight short side to short side and long side to long side. Okay, and I highlighted the sides that were known, that had values. I didn't do the long side with a blank on it because that wasn't very helpful. Now, I know the two long sides, okay? Because on the short side, this one is an unknown. And I don't want to work with unknowns. I have to figure that out, okay? So start with unknown. I'll start with known values. So known values are scale, and identify your scale factor, okay? Your scale factor is going to be image over pre-image. So image over pre-image. Now, determining which one is your image and pre-image is also important. Okay. Now, we are trying to figure out, let's do this in different colors. We're trying to figure out this one. This is our unknown. So we are going this way. We are going to go in this direction. Okay. Because we don't know what that x is. So we're going to go to that x and figure it out. Okay? So what that means is in your image and pre-image, this one, okay, becomes our image. Because we're going to use the small one, okay, and make it larger. So we're going to need that known value to make it bigger. So that image is going to be 20, and the pre-image is going to be 14. This is our scale factor, 20 over 14. Now, I don't want to use that number. That's a little bit weird. I'm going to reduce this, and I'll get 10 over 7. That is my scale factor. Okay? Now, it's not necessarily asking for scale factor, but I need that as my tool. Okay? I need that as my tool to figure it out. Okay? So we are going to do the same thing for the 6 to the x, short side to short side. We don't know that part. Let's do that in red. Short side to short side, okay? We don't know, so we're going to try and figure that out, okay? So I start off at 6. This is my pre-image, okay? And I'm going to multiply by my scale factor. I should do that in green. Okay, this is my scale factor. Okay, and then I should get my my image value. Okay, so let me plug in some numbers here. My scale factor is 10 over 7. 10 over 7, that's my scale factor. I got that from here. Scale factor. Okay. 6 times 10 over 7, and then I should get my x value, my unknown, this part. Okay? Now, how do I multiply 6 times 10 over 7? Well, when you write it out, it'll look like this. 6, put in your calculator, times 10. 6 times 10, that's this part. Okay? And then we'll do this part, divide by 7. Divide by 7. That's exactly what you type into your calculator. That's how you multiply by fractions in your calculator. 6 times 10, divide by 7. Okay? So let's figure that out. I don't know that off the top of my head. So 6. No thanks. 6 times 10 divided by 7. What you notice is right here, okay, right here is exactly what we wrote down here. And that's how you enter it into the calculator. Right here. 6 times 10 over 7. Okay, and we get 8.57. So we now know that x is equal to 8.57. Okay. X equals 8.57. There we go. Okay, now you don't have to do this page. Remember, you're only doing this page here, so you only have 2 of those problems. It's not a lot, but we're going to get to the level where we're very, very comfortable with that, and we're going to be doing a lot of those. Okay, here you're going to look for just the scale factor. Here you're just identifying the scale factor. You're not finding unknowns. Okay, you're just measuring side length to side length, short side to short side, how much change is happening. Okay, how much. All right, that should be it. Please make sure that I get a good report from your sub, and I'll see you guys next week.